Very good morning. Today we are going to see about the disadvantages of the low power factor. In the last class, we have seen about the power factor and what are the how it is being calculated. So, what are the effects of the power factor? Today we are going to see the disadvantages of low power factor. The power factor plays an important role in AC circuits since the power consumed depends on the power factor. Whatever the power is being consumed, it is depends on the power factor. So as you all know, like P is equal to BL IL into cos phi, where IL is the load current and BL is the load voltage. Cos phi, cos phi, you know the what is cos phi means power factor. So if you take IL outside, so IL is equal to P divided by VL cos phi. This is for single phase AC supply. Say for example, three phase AC supply, P is equal to root 3 VL IL into cos phi, where IL is equal to P divided by root 3 of VL cos phi. So it is clear from the above that fixed power and voltage, the load voltage is inversely proportional to the power factor. So the load voltage is inversely proportional to the power factor. That is load current. Load current is inversely proportional to the power factor. So what is the relationship between the load current and as well as the power factor? So IL is equal to 1 divided by cos phi. That is IL directly proportional to 1 divided by cos phi. So load current is inversely proportional to the power factor. So lower the power factor, higher the load current. So if the power factor is lower, say for example, power factor is 1. Power factor is 1, cos phi is equal to 0. The power factor is 1. Then the load current might be good. If lower the power factor, higher the load current, and vice versa. So if power factor is, say for example, it is decreasing. Okay, so now it is 1. So load current is somewhat like constant. So if it is decreasing, like a power factor is going up to 0.8, so automatically load current will be decreasing. Okay, so load current is decreasing means again the some appliances will misbehave. So each and every equipment in our home having some different load current ratings. Say 5 amperes, 10 amperes, 15 amperes. Maximum withstand capacity is 10 amperes. Sometimes grinder if you take, so 10 amperes, 15 amperes. Refrigerator 10 amperes, normal ceiling fan and all 5 amperes, and normal all the appliances are 5 amperes. So in your induction stove will have some 10 amperes. Like if you see the okay, that plug, like a plug that is coming from the refrigerator, washing machine and all, what we will do is we'll make a separator 15 ampere switch or 10 ampere switch. So definitely we'll go for some higher amperes. Even though it is 10 amperes, we'll go for 15 ampere switch, 20 ampere switch, so that it can withstand, can that is plug can withstand that higher rating of the current. So like that we are doing. So here also by varying the power factor, automatically load current will be varied. So what are the major disadvantages? So a power factor is less than unity, results in following limitations, disadvantages. The first limitation is larger kVA of the equipment. Larger kVA of the equipment means your transformer, your transformer size and alternator size, your nearby distribution transformer size and the alternator size, your generating units, there will be having alternators. So that size and the switchgear size will be increasing. How? In the sense, so kilowatt amperes, that is reactive power is equal to kW divided by cos phi. Kw divided by cos phi. So this Kw divided by cos phi. So it is clear that kVA rating of the equipment is inversely proportional to the power factor. So kVA is inversely proportional to like a proportional to 1 divided by cos phi. That is inversely proportional to cos phi. Therefore, at lower power factor, the kVA rating of the equipment has to be made more, lower the power factor, so kVA will be increased. Okay, so if the power factor is higher, like equivalent to 1, the kVA will be normal, as like distribution transformer size will be of 11 kV bar 415 voltage. So if the like kVA rating of the particular say for example power factor is becoming lesser, lower the power factor. So KVA rating might be increasing. So you have to increase the KVA rating of the transformer. Whereas you can't increase the KVA because the rating itself 11 KVA transformer. So 11 KVA, 11 kV bar, 415 volts transformer. So KVA rating, if you take like 1 KVA or 5 KVA, 10 KVA like that. So simply like that, your KVA will be like kilowatt amperes will be increasing. So we can't able to increase the go nearby to the transformer, and we can't replace the transformer by the time when the power factor is less. In that scenario, what your transformer will be heated up like anything. Your transformer will be heated up like anything, like the oil inside the transformer will be boiling. Sometimes those who are like standing near to the transformer, that oil will come out and it will spray near to the like whoever standing nearby, even cattle, human beings, whoever standing nearby. Sometimes that oil will spray. So imagine that oil might be of more than 200 degrees Celsius. Okay, 150 degree or 200 degrees Celsius. 200 degrees Celsius oil, if you pour in our skin, means so simply like that, bubbles will come out from that from our skin. So it is very very dangerous. Sometimes it will if it is spraying on your skin, if it is directly spraying on your eyes or your face, like that, injury will be of like anything. Okay, so like that, so in industry what they will do is they will be very very careful about this term cos phi. Caused by in future, you are going to become a like a electrical in charge, or like a engineer of a particular electrical engineer of a particular company, electrical in charge of a particular company. You will be working in your transmission companies or distribution companies or generation companies. So this factor, that is cost phi factor, is very very important. We have to maintain that cost phi near to the constant, that is 0.99, like that. You have to maintain this cost phi. Otherwise what happens is simply like that, your all the equipment in the substation will heat it up like anything. And the size of the conductor, so next point is like kVA rating of the equipment made more, making the equipment larger and expensive. So expensive also. So in a substation what they will do is they will on some other transformer also. You have to on some backup transformer also, so that to handle that situation. Or otherwise and like that particular transformer will be heated up and misbehaving also sometimes. So next is greater the size of the conductor, greater the conductor size. So to transmit or distribute a fixed amount of power at constant voltage, the conductor will have to carry more current at lower power factor. So if you are maintaining lower power factor, the conductor size will be more. Conductor size will be more means the heat loss, the conductor will heat it up like anything, and heat loss will be there. So due to that that transmission loss will be there. So whatever the power we are sending, it will be not receiving, because due to the heat losses, that much current will not be receiving at your home. So here in your home also, some equipment may misbehave, some equipments will not get heated up, will not get on. and some equipments, your refrigerator will have some sound. So simply like that sound will be coming from that particular motor. Yeah, that refrigerator will not do the particular operation, even though it will not do the cooling. Even your AC is also, even though you are fixing the regulators, even though your AC is also sometimes will be just running. Your motor will be just running, you'll not feel any coolness. So that also will be happen in our home. And one in industries, this is a very very important thing. Why? Because while running induction motors of larger size, induction three phase induction motor, like 10 induction motors or 20 induction motors will be running in a particular industries. So in that, automatically the power factor will be getting lower. So if you are working as an electrical engineer, so you have to maintain that power factor constant. You have to maintain that power factor constant. So that what we are doing is we are going for capacitor banks, static capacitors, synchronous condenser, phase advances to manage that power factor. That is lagging power factor will be there. Point 0.7, point 0.8 will be there. So what we are doing is we are leading that power factor by connecting the capacitor bands or synchronous condenser like that. So that is a very very important. I know some of the electrical in charge may lost their job due to not maintaining the power factor. So I know one friend. So he was working previously. He was working as an electrical in charge of a very big company. He is the whole in charge of the particular company. So he is the responsible to maintain all this power factor, frequency, everything constant in that particular company, and also voltage profile. Sometimes due to some carelessness of the workers, under him, some 10 workers are working. So due to that carelessness of that worker, they didn't maintain that power factor. So if they didn't maintain the power factor means nothing they may going to lose, but frequently monthly once. So some electrical engineers, assistant engineers, vigilance will be visiting to that particular company to check that power factor, to check the power factor. So what they will do is they will they will read the whole month power factor, how the power factor profile they are maintaining. So in that particular company, I think they are paying around 20 lakhs per month for the like as an electrical tariff, 20 lakhs per month. So they failed to maintain this power factor. So for some days, 10 days, they didn't maintain the power factor profile. So what they did is from that electricity board, they made a penalty tariff of around 3 lakhs, 3 lakhs for that particular company. Even they are paying only 20 lakhs as a tariff. So 3 lakhs they paid as a extra, 3 lakhs extra they paid for the power factor tariff, power factor penalty tariff. So he lost his job. Why? Because uh, for not maintaining, as an electrical in charge, you are not maintaining the power factor. Then why to continue the job like that? He just fired out from that particular company. So imagine this is the for the very big company. If you take like small companies of 50 workers, 100 workers will be working. So there also they have to maintain the power factor, because if very big company they can easily manage this tariff amount. 3 lakhs is not at all a very big matter. But if you take like small companies, even if they have to pay 50,000 or 1 lakh, their profit itself will be coming around 5 lakhs, 10 lakhs per month. So if they pay 1 lakh as a penalty tariff, then definitely some workers, electrical in charge or a maintenance engineer or an electrical supervisor, has to lose his particular job. So this is very very big thing in the industries. If you go to any industries, there will be a separate unit power, like power. Uh, like there will be a separate unit of maintaining this. There will be a capacitor banks, okay, so that they will maintain this power factor as a constant. So for example, in the case of single phase AC motor having the input of 10 kilowatt on the full load, the terminal voltage of 250 volt at unity power factor, the input full load current would be, okay, full load current would be this I is equal to this P by V. So power, what is the power? 10 kilowatt. So 10 into 10 to the power of 3 divided by 250. So that is nothing but 40 amperes. Imagine same like that, point 0.8, it is maintaining the power factor as point 0.8 power factor. So for point 0.8 power factor, the kVA input would be this 10 divided by zero point 0.8, that is nothing but 12.5, 12.5 kilovolt, so 12.5 kV, 12.5 kV. So imagine the current output would be uh, like 12.5 kVA, that is 12,500 divided by 250, that is 50 amperes. So 10 amperes is increasing. So if the power factor is you are maintaining the power factor at zero point 0.8 in the industry. Okay, so 10 amperes is increasing. So we have installed the conductor size. We have installed the conductor size, wiring size that have maintained the 40 amperes or plus or minus 10. We will go for definitely will not go for only 40 amperes to flow in the particular line in the industry, like that, plus or minus 10. So say for example 50 amperes, say again this power factor is decreasing up to 0.75 or something like that. This 50 amperes will rise up to 55 amperes or 60 amperes. So that if it is increasing up to 60 amperes, imagine that wire can withstand only 50 amperes. So due to the load current, that wire is taking 60 amperes. So the wire sometimes it may cause fire also. Sometimes simply like that, the whole industry will get fire. The wiring will get fire. So due to the wiring get fire, the whole machineries and all will get fired. So that is a very very huge loss of industries. That is a very very huge loss of industries. We have to claim for insurance, like that. That is a very very big task. They will not allow. So that is why the electrical maintenance supervisor or the electrical engineer have to look on to this particular issue always. Okay, and also if they are not maintaining in the power substation also, what they will do is they will simply switch off the power in that particular feeder where the that industry is connected. If they are maintaining lower, more like point 0.7, point 0.6, like that. So defaultly in the substation they will be knowing. In the substation, power factor also will be increasing, so that they will simply cut the feeder for 2 hours, 3 hours, so that a particular machine will not work for 3 hours. Means imagine, yeah, shampoo packet company. Okay, so they are giving the shampoo packet for like 2 rupees, 2 rupees shampoo packet. So in an hour they will be going for 1,000 packets or 5,000 packets. So their profit in that particular packet is 50 paise. 50 paise may be their profit. So 2,000 packets means 50 paise means one hour they have to manufacture 2000 packets, means 50 paise means around 1000 rupees. 1000 rupees is the profit for one hour. So that a company is working for the whole 24 hours. So if the company is working for 24 hours, so one day profit is 24,000, approximately 25,000. uh, okay, so one day profit of that particular shampoo packet company is 25,000. So if the power is not coming for due to the less maintenance of this power factor, so in substation itself they are cutting the power for sometimes 2 hours, 3 hours. So they will be losing 3,000 rupees as a profit. So one day 3,000 means in a month 30,000. So okay, 30,000. So 30,000 is two workers' salary. 30,000 profit means two workers they will be losing their jobs. So this is a small company. This is a small example I have said. So imagine that is of this profit might be of 1 hour profit might be of 1 lakh rupees. Okay, so 2 hours the power is not coming means 2 lakh rupees the profit is less, loss. 2 lakh rupees the profit is loss. So 2 lakh rupees profit is loss for one day means in a month around 60 lakhs. 60 lakhs in a month they are losing. 60 lakhs means around maybe 100 workers are okay, 200 workers or 300 workers may lose their job in that particular company. So why I am saying is this is the seriousness of the power factor, seriousness of the power factor. And also if they not maintaining here like if they are not maintaining frequently, not maintaining, they will go for a power factor tariff for 5 lakh rupees or 10 lakh rupees. So that is also loss for that particular company. So they will be very careful about this power factor. So next is larger copper loss. So larger current at lower power factor causes more IR square losses. More IR square losses, that is heat losses. IR square losses, heat losses in the all the elements of the supply system. In the, all the equipments of the supply system, this results in poor efficiency. Poor efficiency in the sense, imagine your transformer also not maintaining this. So transformer, what is the efficiency of the general transformer is around 99 percentage or 100 percentage you have to maintain. But due to in practical, due to some losses, iron losses and core losses in the transformer, it will come like 99 percentage or 98 percentage it will come. Imagine the same thing you are doing the experiments in the laboratory also. You are going to find out the efficiency of the transformer in laboratory transformer. I think you are getting 97 percentage, 98 percentage, 96 percentage like that. But it has to come like 99 percentage. Some 1 percentage losses may be there in your core loss or iron losses. More the efficiency, then the losses might be very less in the system. So the power transmission might be of increasing like anything. So even transformer itself not maintaining the efficiency, transformer going the efficiency is going down up to 80 percentage, say 80 percentage. Again some other equipments like bus in the bus system, then your protective equipments, everything you will be losing the efficiency like that. So imagine the like whole substation is having only 60 percentage efficiency or 70 percentage efficiency. By that case, 60 percentage, 70 percentage efficiency. So in that particular scenario, the whole the distribution end, you should the efficiency is very less means the even the power what we are getting is also will be decreasing, and loss voltage will be decreasing, the load current will be decreasing, like the whole system will get collapsed. So in that scenario, simply like that, what they will do is simply like that, if efficiency of the particular substation or power generating system will be decreasing, simply like that they will shut off the whole substation itself. By that case, if they simply go for supplying the power to distribution system also, in that scenario, many equipments will be get failure. So you will be having some cases like the whole in the particular area, the whole televisions will gone off, the whole like ceiling fans will gone off, and the whole like grinders or mixies, whatever the equipments running in that particular area will be like get damaged, like that. Some news is and all coming in the newspaper. So like that, due to this efficiency or due to the less power factor, like that, this accidents may happen in the our area also sometimes. So that will not be happen, that will not allow that particular substation to happen. But even though I am telling, even though the worst scenario, if it happens now, ultimate losers is ourselves only. Ourselves means consumers like domestic consumers as well as industrial consumers. So next is poor voltage regulation. As I said, larger the current at low lagging power factor causes greater voltage drops in alternator, transformer, and transmission lines, and as well as distributors also. Distributor also. This results in decreased voltage available at supply end. Decreased voltage available at supply end, thus impairing the performance of the utilization devices. So performance of the utilization devices will be decreasing. So lifetime of the our devices will be decreasing. We bought a new induction stove this Pongal or this Diwali. So they will be giving the uh, like 1 year warranty or 2 years warranty or 5 years warranty. Imagine that appliances going down to only 6 months. That is coming only for 6 months or only for 1 year, like that. So ultimate loser is ourselves only. So again, we need to spend some money for replacing some switches, IGBT switches in the induction stove. Then some other you need to replace some other equipments, some other devices in your our appliances. So that ultimate loses in ours only. So in order to keep the receiving end voltage with the permissible limits, extra equipment, that is voltage regulator, also will be required. So we need to install a voltage regulator in our home, like all the appliances, refrigerators, then ACs, TVs, older TVs, and even now the LED TVs also. They are asking to go for this regulators, even though the regulators are installed inside the equipment itself. So to safeguard that particular appliances, we are going for extra regulators, voltage regulators is also required, so that the cost will be increased. Simply like that, cost will be increased. So imagine it will cost, the voltage regulator will cost about 3,000 rupees, 3,500, 4,000, like that. We need to simply spend for this voltage regulator alone. And also voltage regulator also they have to, like the distribution companies have to install nearby to your distribution transformers, then in substations, like that. So cost of the maintenance of the substations and maintenance of the transmission lines and the distribution system will be increased. So defaultly, so what they will do is they will collect the tariff, they will collect some extra tariff for installing some other equipments from us. So 50 paise or 1 rupee they might be increasing for our from our tariffs. So ultimately we have to pay for that. Next is reduced handling capacity of the system. So lagging power factor reduce the handling capacity of the all the elements of the system. It is because of the reactive component of the current prevents the full utilization of the installed capacity. So full utilization of the installed capacity also that will be decreasing. So the above discussion leads to the conclusion that lower the power factor is objectional feature in the system. So this so we have to maintain. So we have to maintain that power factor as a constant, even though it might be decreasing. We have to maintain. So what are the causes of the low power factor? So lower power factor is undesirable from the economic point of view. So economically, you have to spend more on that. Normally, the power factor of the whole load on the supply system is lower than zero point 0.8. So due to the following reasons. So most of the AC motors of induction type, most of the AC motors of induction type, that is single phase, three phase induction motor, which have low lagging power factor. Low lagging power factor. These motors work at power factor which is extremely small on the light load and rises to zero point 0.8 or zero point 0.9 at full load. Sometimes I have seen a practical case without informing. In our home also, sometimes we will be constructing new houses without informing your lineman. What we'll do is we'll just do some welding in our homes, welding in our grills and the gates, like that, for constructing our house. So what they will do is that technician will come up with a welding machine to directly to our home, and they will be operating the welding machine in our home. So that also sometimes will be noted by our substation, because that if if you are using welding machine in a single phase supply, so there will be some limit. Only you should not exceed 10 amperes or 20 amperes, 15 amperes, like that. There will be some limit. So if you are using a particular welding machine in a single phase supply, that will be taking more amount of current. So that if you are using like a welding machine in single phase supply in the peak hours, so sometimes nearby our home also, nearby some neighbors also will be taking some less voltage. They will be feeling some less voltage. Sometimes nearby house also some appliances will misbehave, like that. That will be monitored. That will be monitored in domestic lines. Some power factor is maintaining less. That will be monitored by the substation also. So from the substation, they will be intimating to that particular lineman in charge, so that lineman will go for some frequent check. So where that induction something this welding machine is operating, like that. So they will also sometimes fine us. So with the intimation to the lineman, or with the intimation to the substation, if you operate, no problem. So what they will do is that particular time. If you are using means, so priorly if you are telling to lineman, so lineman also will be intimating to the nearby substation, so that this particular area they are going for some construction work for 5 hours or 6 hours. So that what they will do is they will feed some more current in that particular, they will feed some more voltage that particular line, feed more power in that particular line, or sometimes from the substation itself. So to avoid this unexpected power factor, it will be reducing like unexpectedly. So sometimes in our substation also, even without intimating, you are doing like this. You are operating welding machine, or you are operating some induction machine of you're maintaining the belts, something like that. You're without intimating, you're doing something. So in the substation itself, they will not able to find out where the exactly the thing happened. Exactly. So what they will do is from substation, they will call to industries. So substation, the industries, they may tell like we are maintaining a very good power factor only of 0.95 like that. So what is happening like that? They may telling to substation, and even in the domestic side also sometimes this power factor will be going down very less also. So they will wait for some 10 minutes, 5 15 minutes like that. Simply like that, they will open that feeder simply like that they will open the feeder. So sometimes they will fine also if you are using this type of welding machine in a single phase supply without intimating like that. They will fine also, they will come to our home, and they will easily find out, they can easily find out, they may make fine also, and they will simply disconnect our supply for 1 day or 2 days like that. Also they may do. So this is a very very worst case. Like in some other, in some villages, what they will do is without taking three phase supply, with a single phase supply itself, they will run a small scale industries around. They will go for a small scale industries operating some many induction motors in that particular thing. So without getting the commercial like tariff line, they may go for simply domestic supply, and they may be operating this thing also. That is wrong. Usually you should not do like that. So that is a very wrong thing, like that. So you may complain also. So somebody might be using they might be taking single phase supply, and they may be running a small industry, small scale industries with more like motors, with the more grinders. Sometimes what they will do is with the in the home itself, they may go for 10 grinders, some other grinding machines. They will run a small grinding machine like that. So that also without taking commercial three phase supply tariff, they will be running simply like that single phase supply itself. So that is also very very wrong scenario in some villages they are doing. That is also without intimating. So sometimes your lineman will know. Lineman will know whoever is doing these things, this kind of things. So they may simply find. So you may also make a complaint if nearby your places they might be doing this type of things. And also this type of arc lamps, then electric discharge lamps, and industrial heating furnace operate at low lagging power factor also. So industrial heating furnaces will take if induction type heating coil will be there inside the furnace. So that also will be taking the will be giving the low lagging power factor. So this also. So in while operating our induction stove also, our power factor will be going down. But in induction stove, there will be some leading some capacitors, so that it will lead the power factor. Sometimes that capacitor, due to that capacitor failure also, your induction stove will not be working. So if you take that induction stove to your service center, so simply like that they will replace that capacitor, so that again you can operate that induction stove. Next, load on the power system is being high during morning and evening, and low at other times. So high during the morning times, and evening times load on the power system will. So by that time also during the load period, so supply voltage will be increased, which increase the magnetization current. So this results in decreased power factor. So during the low load period also, the supply voltage is increased, which increases the magnetization current. So this results in decreased power factor. So normally there will be some average load will be there. Average load will be there in your particular area. So suddenly, what it is happening means sometimes like in the government recently the government told us to simply switch off the power for sometimes so that corona will go like that and all they will be advertising, no. So in that time like exactly say 6 months or I think at May or June, it has happened. May month, last year, May month, it has happened. So in that particular time, the whole India's, the whole, if you take the whole India's power factor, it has gone up to, I think, point 0.7. It has gone up to point 0.7. So simply like that, what they did is in substation. In many areas, they simply okay simply they reduce the generation, and also in substation they simply open the feeder. They simply open the feeder also. So this kind of things also sometimes some government is encouraging to off the supply for sometimes so that corona will go like that. Many superstitious things are not there, but due to that also in that scenario also the whole, if you take like the whole Telangana load, even many states the power factor will be going decreasing like anything, decreasing like anything, so that we can't able to manage the efficiency and properly. So in the generating station itself for 1 hour or 2 hour, what they did is they reduce their simply reduce their like generation. So in that time, you're from the generation corporation also, there is some intimation like, so don't on all the, don't off all the loads. Okay, so simply like that you just only off your light itself, only off your some light itself, don't off all the loads, like that also intimation they are giving, intimation also giving. So this is of waste. Like in some other states, what they are doing is they are making the thing go corona go like that and all. They are just like that telling. So corona is not still going. So what you people have to do is you have to maintain the social distancing. Don't go outside unnecessarily. Don't go outside, and nowadays this is airborne, use airborne. So easily if you go to some common places like theaters or shopping malls, easily you can get. So avoid going outside. So that's why um, government itself they are announcing to take the online classes. So avoid go outside also. Avoid go outside also. And so why I told this in the sense, in that particular scenario, if you take the newspaper readings of that particular month, this power factor has reduced like anything, reduced like a point 0.7, point 0.6, and all. In some other states, point 0.6. So what they did is they reduced their generation, they reduced their generation, and again they increase. I think some 8 o'clock, 8 o'clock to 9 o'clock, something 1 hour. They told no. So 1 hour before 1 hour itself, they reduce their generation because simply like that. Station you can't simply like that you can't off and on. Yeah, you can't simply off and on like normally we are going and switching on our light and all, no. So before 1 hour itself we have to start our generation for thermal generating station. And if you want to close, if you want to shut off that particular thermal generating station also, it will take some 1 hour, because every equipments you have to shut down. Every your thermal station, like as I said, your thermal station has boilers, turbines, then steam output, everything. So you have to shut down slowly, and simply like that. If you shut down, it is very dangerous for thermal station also, and also you can't also emergency stop you can do that too in the worst scenario you can go for emergency stop, but the emergency stop also will be taking more amount. Why? Because we are spending more and more amount of rupees for operating that particular power plant. So if we simply like that, if we go for emergency stop also, will be spoiling all the generation, and also the amount what we spent is very higher, so that we can't simply like that we can't stop. So that is also there. We can't simply off and on the power station if you are not utilizing, you're not utilizing the load constantly. So whatever the power generation will be coming like a reactive power. Reactive power will be very more. Reactive power will be very more. In that scenario, your power factor will be very less. So constant load, always maintain constant load. Don't go that much high, or don't go very low also. So averagely. So that's why if you are applying for a single phase connection or three phase connection, they may calculate. They may calculate. They may come to your lineman, so will come to your home. What they will do is they will calculate how much lights are there, how much ceiling fans are there. It's like how much motors, like pumping for pumping water, how much motors we are using. Like that, averagely they will be calculating, and they will suggest you to go take single phase supply or three phase supply. If the load is more, then they will suggest you to go for three phase supply. If the load is somewhat lesser, then they will suggest you to go for single phase supply. If you are using ACs and all, they may suggest you to go for, if you are using one or two ACs more, like 210 ACs or above 110 ACs, they may suggest you to go for three phase supply. Three phase supply. So like that also it is happened. So this power factor is very important factor in our system. So you have to maintain this power factor. So as a domestic suppliers, we also sometimes we also have to as a electrical engineers, we know in which time we have to operate like that. But don't go for like peak time hours. Don't go for on your motors, pumping motors like that in your home itself. So that's why what we'll do is at the later hours, like after 10 o'clock, 10 p.m. What we'll do is we'll just simply on our motors instead of or otherwise early morning 6 o'clock or so, it's like that we'll simply on our motors, or night time after 10 o'clock we'll simply on our motors. So in some places there is they knows your mom and dad or your grandfather grandmother, they knows better than us. Why? Because they will tell don't on the motors in the like evening hours, like that they may tell. So to avoid this also will maintain. This also helps the substation or your generating station to maintain the power factor.